Now we'll see the next part of digital electronics. There are two types of circuits. One is combinational circuit and the other one is sequential circuit. In combinational circuit we have circuits that's output is dependent only on present inputs and it is not dependent on the present state of the circuit. Sequential circuits on the contrary produce output uh, and the output is dependent on the input as well as present state of the circuit. If you look at the statement, combinational circuits where the input values explicitly determine the output, means its output is dependent only on the present state of input, only on input. Whereas the second statement, sequential circuits, where the output is a function of input values as well as existing stage of the circuit, means its output is not only dependent on the input but also dependent on the present state of the circuit. There are few circuits that we're going to consider in sequential circuits part. The first one is latch, and then we will have different flip-flops. A latch is an electronic logic circuit that has two inputs and one output. It stores a data value. It stores one bit. It is non-volatile, will not lose value over time, and often incorporated with a static memory. Technically speaking, a latch is a level triggered circuit and a flip-flop is a edge triggered circuit. There are a few types of flip-flops, and those are SR, that stands for set reset, D stands for data, T stands for toggle, and JK. Okay, these are the types of flip-flops we are going to study in this part. Okay, the first one is SR latch. In SR latch, operation is simple. It is implemented with the help of two NAND gates and two NOT gates. If you look at the NAND gates, you can see output of one NAND gate acts as input of the other NAND gate, and NOT gates are there at the input side. So how it functions: the latch holds or stores data, whatever there is in the memory. It holds that data if inputs S and R both are 0. Okay, this S and R will decide whether it will store or not. So it will store data if S and R both inputs are 0, and it will set, the output will be set, means it will make its output 1 if S is 1 and R is 0. S stands for set and R stands for reset. Therefore, if S is 1, it will set the latch, means it will hold 1 in its memory. In the third case, it will reset. Okay, it will reset if S is 0 and R is 1. S is 0 means it will not set. R is 1 means it will reset. Reset means it will produce 0 in output. So these are three possible conditions. Apart from that, there is one more condition in which S and R both are 1. So when S and R both are 1, it will produce unpredictable output, and that is called as race condition, and that is not allowed. Means we do not apply this particular input to the circuit, otherwise circuit goes into racing condition. So this is all about your SR latch. Then we have got one more SR latch with enable signal. If you look at this one, this circuit and this circuit, you can identify that this part is common. Okay, and there is change in this part. Fine. At the input side, we have NOT gates here, and here we have got NAND gates. Okay, and here we have only two inputs S and R. Here we have three inputs S, R and C. C stands for clock, and that acts as an enable signal. Okay, so output is dependent on three inputs now. Here in this case, here it was dependent only on two. So why do we have this enable signal? Because a clock determines when computational activities occur, and signals determine what computational activities occur. What is case of this circuit, which has no enable signal, is it will produce output as and when input is present. Okay, but in this case, in the SR latch with enable signal, it will produce output only when there is suitable clock position, there is suitable time. Okay, it will produce that particular output only on either falling edge or rising edge or level, high level or low level, that we can decide. But in case of this circuit, it will produce output at any time. That makes further design complicated. Therefore we have got SR latch with enable signal. So SR latch with enable signal can be explained with the help of this truth table. We have two columns, S and R. S stands for set, R stands for reset, and C stands for clock. All clocks are shown like a falling edge clock. Okay, a clock has got two parts. This one, okay, this is your clock. This one is called as rising edge. Okay, rising edge is this part of your clock, and this part of your clock is falling edge. So this is falling edge and this is rising edge. Okay, so in the column it has shown falling edge. So three things must be there at the input side as per the circuit diagram: set input, reset input, and clock. As per the definition of a sequential circuit, its output is dependent not only on the present input, but also it is dependent on present state of the circuit. Therefore the present state is shown by Qn, and the next output is given by Qn plus 1. Okay, so Qn is present state and Qn plus 1 is the future state. After applying typical combination of inputs, how Q1 gets modified, and that output is labeled as Qn plus 1, right? So for SR 0 0 and falling edge, if Qn is 0, Qn plus 1 will also be 0, means in the output there will be no change. If Qn is 0, Qn plus 1 will also be 0. Secondly, if S and R are 0, falling edge is the clock, and if Qn was 1, Qn plus 1 will also be 1. It means that for this case, S and R 0, whatever may be Qn, Qn plus 1 will always be equal to Qn. So Qn will continue to remain as it is. That is why in description column it is said that the SR flip-flop will hold the data. Whatever is the Qn, it will continue. In the second case, S and R, this column, S is 0, R is 1. The falling edge is the position of clock, and let us consider Qn was 0. Then Qn plus 1 will also be 0. Now take another condition where S and R are 0 1 respectively. Clock is also a falling edge. Then if Qn was 1, then it will become 0. Now here we have to take care in this column when input is 0 and 1. Okay, so S is 0, R is 1. It means set is 0, reset is 1. By theory, it has to reset the flip-flop. Reset the flip-flop means what? You have to produce 0. If there was already 0, it will not make any change. It will keep 0 as it is. But there was 1 and you applied this input, it will reset the flip-flop. It will make it 0. Right? That is what it is shown. If there is 0 previously, it will continue. It will continue. Okay, but if there was 1, it will be made 0. Right? That is your reset. So in the description column, it is said clear or reset. Depending upon different authors, they call clear, some call reset, etc. Then third possibility, in third condition, we have S column 1 is R column 0, and there are different possibilities of QN. As we know that S stands for set. So for this kind of input, S and R equals 1 0, the flip-flop has to set. So if you look at this condition, when Qn is 0, it is made 1. But if Qn is already 1, then it remains as it is. So for SR is 1 0, Qn plus 1 will be 1, whatever may be the Qn, be it 0 or 1. The last row for SR 1 1, it is indeterminate, and we avoid this kind of input because the output of flip-flop becomes unpredictable. It goes on ringing around 1 and 0. That is why we don't apply this kind of input. This is how the SR flip-flop works. Only one thing we have to keep it in mind, that if S and R are 0, both of them are 0, the last output will continue, be it 0 or 1. If S and R are 0 1, it will reset the flip-flop. Qn plus 1 will be 0 irrespective of Qn. If S and R are 1 0, then Qn plus 1 be 1 irrespective of Qn, be it 0 or 1. And S and R are 1 1, then we do not apply such kind of input to the flip-flop. Write race around condition, or simply write indeterminate in the response column. This is about your SR. Then we have D type of flip-flop. D stands for delay. This is the circuit diagram. Okay, the circuit diagram is same as per SR flip-flop. The only change is that S and R, these two inputs are looped, means we have connected this S and this R through a NOT gate. That's all, nothing else has changed. Now if you look at the truth table, this is truth table. We have two columns, D and C. D for data, C for clock. D stands for delay. Okay, it will delay the output. That is the only logic. If Qn is 0, Qn plus 1 will also be 0. If Qn is 1, sorry, for 0, first look at this data column D. If D is 0, then it will reset, it will clear the data. If Q is D is 1, it will set the data. So this is how it works. So if Qn is 0 for D0, then Qn plus 1 will be 0. If Qn is 1 for D0, Qn plus 1 will also be 0. If D is 1 and Qn is 0, the Qn plus 1 will be 1. If D is 1 and Qn is 1, Qn plus 1 will be 1. Okay, so this is how your D type of flip-flop works. D flip-flop, it acts as a simple memory of latch. The previous value is stored, Qn, has no effect unlike other flip-flops. It therefore acts as a simple memory or latch. The most widely used flip-flops, simple to build and design. A register comprises of several D flip-flops, one for each bit to be stored. Okay, so this is a little theory about D type of flip-flop. There are so many words that you would not understand exactly what are those, because there is no connection with these words as far as syllabus is concerned. Therefore, you have to remember these statements. The JK flip-flop has removed the disadvantage of a SR flip-flop. What is problem with SR flip-flop is when you apply SR, that is input, both 1, then your flip-flop does not work. It does not produce definite output. That is called race around condition. That race around condition is removed with the help of JK flip-flop.